Hello and welcome to the solution video. If you like this, please give it a thumbs up, share with your friends and subscribe to Math United. Let's get started with question number 1. Find the quotient of remainder, quotient and remainder when this polynomial is divided by x square plus 5. So let me use a long division method because it is a quadratic divisor. So x4 minus 3x cube plus 9x square minus 12x plus 27, we have to divide it. So compare the leading term here and here. We need to multiply x square with x square so that we get x to the power 4. So x to the power 2, so that we get x to the power 4 here, and x square also multiplies with 5, which gives us 5x square positive, and we will subtract the lower one from the upper one. They will change their signs, this will cancel out, and 9 minus 5, 4x square will be here, but these will be just copied because they are just being translated down, nothing else. Okay, now I need to make this x square minus 3x cube, so I need to multiply with minus 3x. It will be minus 3x cube plus 4, not 4, yeah, you can write that later. So when 5 multiplies with minus 3x, we get minus 15x. So we'll subtract again. This becomes positive, cancel out. So it will be 15 minus 12, 3x positive here. 4x square is already there, and then 27. Now I need to multiply x square with 4 so that I get 4x square. So I'll write 4 here. So 5 times 4 is 20, so 20 will be here, not there, and they will change the sign, cancels out, so we get 3x here plus 7. So we got our remainder here, and this is the quotient. These are the two things they were asking. Question number 2. Find the coefficient of x square in the expansion of this one. So let me write it properly. 2x minus 5 is the first factor, and then we have 4 minus x square rooted. We can write this as 4 minus x to the power half, positive half. So I hope you understand this one. 1 plus x to the power n. The expansion is 1 plus nx plus n minus 1 over 2 factorial x square and so on, right? This is binomial expansion. So this is what I will do with this right part. Second, the left one is complete, so we will not touch it, we'll just copy it down. So 2x minus 5 remains what it is, but we will apply this here. But can you see, we have 1 here, it is 4 here. So to convert this 4 into a 1, we'll do this. So let me do it here. 4 minus x to the power half, I want to convert it to something else. So what will I do? I'll multiply this by 4, divide it by 4, and divide this also by 4. In other words, I have divided the content of this particular bracket by 4. So I have to multiply also by 4, and that I'll do outside. Okay, but when I divide both the terms by 4, I have to take care that it is power half also. That power half will be applied to this 4 also, which we are multiplying here. And what is square root? 4 to the power half of 4 to the power half, it is 2. So I'll write 2 here. And 4 over 4, 1 minus x over 4 to the power half. Now it matches with this. In place of plus x, we have negative x over 4. So these x's will be replaced by that. So let me continue. 2x, let's write 2 here now. So this 2 has been written in front. And now we'll expand this. 1 plus n is the exponent, which is half in this case. X. In place of x, I will write minus x over 4. Okay. Now, n, which is half again, multiplied by n minus 1. Half minus 1 is minus half. Divided by 2 factorial, which is just 2. In place of x square, we will write minus x over 4 to the power 2. So this is, this one had no x, this has x power 1, this is x to power 2, then we'll have x cubed, but we will not go further because we want only x square. Yeah, so x cubed will never give you x square, right? Unless there is a denominator x here, which is not, so we'll just stop here. We'll just write like this. Now we need to focus on x square. So if 2x multiplies with something, it should become x square. What does it multiply with? It will multiply with this term so that we get x square. X is here, total we'll get x square. So let's multiply this 2, then 2x from the first bracket, and then this one, minus x over 8. This will definitely give us x square. So 2 times 4 is 8 and minus x is this one. Now this minus 5, I will write 2 first because this 2 is multiplying with both. So I will write 2 first, distributive property, then I will write minus 5, which is this. And now which one should I select here so that I get x square? This one. So 1 over 2 multiplied by minus 1 over 2 is minus 1 over 4 divided by 2, which is minus 1 over 8. Here this square is applied to negative as well, so it will become positive x square and 4 square is 16. And there is no need to go further because we want only x square. So 2 times 2 is 4 and this negative will make it minus 4 over 8x square minus 10, and this was minus 8, right? And it was multiplying, it was not subtracting. So minus 10 and then this minus will make it positive 10 x square over 16 times 8 is 128. Minus 10 plus 10 x square. Okay. Now both of them has to become 1 because both are x squares and we need their denominators to be same. So let's multiply by 16 and multiply here also by 16. So we get what? Minus 16 times 4, 64 over 128 x square plus 10 x square over 128. So now their denominator is same, 128. Minus 64 plus 10 is minus 54 x square. And the question was, find the coefficient of x square. Coefficient of x square is this. So coefficient of x square is minus 54 over 128, and we can divide it by 2. It becomes 27 and this becomes 64, which is minus 27 over 64. Okay, we have a B part also. State the set of values of x for which the expansion in part A is valid. Okay, since this is power 1, so there is no restriction here. It is a simple binomial. We don't need to look at this. We need to look at this one. So since it is 1 minus x over 4, so whatever follows 1, that is absolute of minus x over 4, that means the absolute of the second term of the binomial should be less than 1. That is the requirement of validity of this expansion. This minus x over 4, its absolute has to be less than 1. So what we can do, we can multiply this minus will go out and become positive and multiply here. So absolute x is less than 4. This is 4 cross multiplies, okay, is the requirement of the expansion. Question number 3. It is given that complex number is minus square root 3 plus I. Express its square in the form of this, where r is greater than 0, positive, and the angle is between minus pi and pi. Okay. So z square, that means we have to square the value of z, which is minus square root 3 plus I. This is z square. This is z square. Okay, so we can apply the identity a plus b whole square is a square plus b square plus 2ab, right? That's what I will use here. So a square, the first term is a, plus b square plus 2ab. So what is minus 3 square? Minus square, so it becomes positive, and square root 3 square is complete 3. I square is minus 1. 2 times square root 3 is minus 2 square root 3 I. So 3 minus 1 is 2, minus 2 square root 3 I. This is z square. Okay. But we have to give in this format. That means we need a modulus and an argument. Okay. R is the modulus. So what is the modulus of z square of this one? Will be square of this number plus square of 2 square root 3 negative. 2 square is 4. And this will, because negative is being squared, so it will be 4 times 3, 12, which is square root 16, right? So R, which is the modulus of Z, in this format is 4. Now we need argument for this particular Z square. So let's visualize this. This is 2, positive 2, which is 1, 2, right? This is imaginary number, which is negative in negative direction, 2 square root 3. So let's say negative 2 square root 3 is here. So our complex number will be here, and its argument will be this angle from 0 degrees, this one, in negative direction. Yeah. So how can I find this angle? We know the base, this one is 2. We know this opposite side is minus 2 over 3, which will take just as a side angle, because it's negative, we already know, so there is no need to look at minus. So this theta will be tan inverse 2 square root 3 over 2, opposite over adjacent, right? 2 and 2 cancel. Tan inverse square root 3 is pi over 3. So because it's in this direction, it will be negative pi over 3. So argument of z square is negative pi over 3, because they said from minus pi till pi. Okay. So now our format of z square in this format will be r is 4, e to the power minus I pi over 3. This is the format. Okay. Next. The complex number w is such that z square w is a real. So what was z square? 2 minus 2 square root 3. So 2 minus 2 square root 3 I times w. Okay, let's assume that w is a plus ib. Let's think about this, okay? A plus ib. So I will write here a plus ib is real. Real means there will be some real part. Let's call it k, that real part, okay, some constant. But there is no imaginary part. They said it is real. Is real. That means no imaginary part. So can we write 0i? Because there is no imaginary part, right? And now we'll compare these with the right side by looking which one will give us I. Because keep in mind, imaginary cannot become real and real cannot become imaginary. Will 2 and this give me an imaginary number? No. So I'll ignore it. 2 and IB, yes, it will give me, let me write it 2BI for simplicity's sake. It is the imaginary part, right? Now, A and this will also give me imaginary part. So minus 2 square root 3a I is equal to 0i. So I compared imaginary part only because I'm sure about it that there is only real part, there is no imaginary part. So imaginary part on this left side should also be equal to 0. So we'll ignore i's and we get this. Let me make this one positive, okay? So 2b equal to 2 square root 3a, if I bring it to the right side, and 2 and 2 can cancel from both sides. So b is equal to square root 3a. This is one relationship that will help us in rest of the part. So I just looked at this one. Now I will look at this one. And z square w, the magnitude is 12. So let me do it here. Z square w omega, actually this w was omega, okay, is same as the modulus of z square over w. This is a property of complex numbers, that if there is a modulus around a division of complex numbers, we can divide them individually also, we get the same modulus. It is equal to 12, that's what they're saying. And the modulus of z square, the magnitude was 4. We got 4, right? So I will write 4 in place of that. So 4 divided by equal to 12. This gives us cross multiplied. The modulus of w is equal to 4 over 12, which is 1 over 3. Now, how do we find the modulus of this one? This is w, right? Omega. So it will be square root a square plus b square is equal to, which is the magnitude of omega, 1 over 3. Okay. Now we will square both sides to get rid of this square root. So a square plus b square equal to 1 over 9. And now we know the relationship b is square root 3a. So let's substitute here. So let's call it 1. Substitute 1 into equation 2. So a square remains a square plus, but b will be replaced by square root 3a. Square equal to 1 over 9. Alright, so a square plus 3a square equal to 1 over 9. 4a square equal to 1 over 9, which gives us a square equal to 4 multiplied with 9, 1 over 36, and we square root both sides. A is equal to plus or minus 1 over 6. This is A. So what is B? B is square root 3 over A, right? B is square root 3 over A. And there will be two answers for this. Why? Because we have two A's, plus 1 over square root 1 over 6 and minus. So first one, plus square root 3 times square root 1 over 6. Second one, square root 3 times minus square root 1 over 6. So those two square roots can multiply, so it gets 3 over 6, which is square root 1 over 2, or 1 over square root 2, or square root 2 over 2. Okay, there are so many ways. So let's write this square root 2 over 2. Okay, now this one, it will be minus 2 square root 2 over 2. So when a is positive, this we got this. When a is negative, we get this. So omega has two values now. They said two possible values, right? That's what they say. Find the two possible values of omega, giving your answers in the form of this. Wow. So we need to do that also for each one. But first we'll write it. So it was a plus ib, right? So a is square root. Okay, so let me convert this 1 over square root 6 to square root 6 over 6. Okay, we can do that, right? How? Some of you may be confused. How? So square root of 1 is 1, square root of 6 is square root 6, and then I multiply here square root 6 and square root 6. So I get square root 6 over 6, and that's what I've written here. Plus I square root 2 over 2 positive. Second one, square root 6 over 6 negative, minus I square root 2 over 2. But the format needed is the one we did earlier. R I alpha. Okay. But R is same for both. Can you see? We got square root a square plus b square equal to 1 over 3. 1 over 3 is the modulus. That's what we got here. So R is 1 over 3 for both. Okay. Now we need to find their angles. So let me draw them here. First, this one, positive something. So positive square root 6 over 6 is here, square root 6 over 6. And this is positive square root 2 over 2. So this will be a positive angle in this direction. For this, it will be negative, this one, negative square root 6, and negative, this also, negative square root 2 over 2. So you can see that this angle and this angle will be exactly same. So I'll find just one of them, and then I'll manipulate to find the angle from minus pi till pi. This is what they're saying. So first this one, this will be tan inverse. This is opposite square root 2 over 2 divided by square root 6 over 6. So if I multiply this, it becomes tan inverse 6 square root 2 over 2 square root 6. So this will give me square root 6. This will give me square root 2. So square root 6 divided by square root 2 is square root 3. Tan inverse square root 3, which is pi by 3 again. Alright. So I got my angle. This is pi by 3. So the first one is R is already there. So let me write omega 1 is 1 over 3 e to the power positive pi by 3. So I pi by 3. Omega 2 is negative. No, not negative. Modulus cannot be negative. So 1 over 3 e to power, and the angle is this big, and that will be minus pi. This angle I'm talking about, this starting from, let me change the color. This is the angle, this is the argument for second one, which will be negative pi, which is negative pi here, right? If I go in this direction, plus pi by 3, which will be minus 3 pi plus pi, minus 2 pi by 3. minus 2 pi by 3. So minus I 2 pi by 3. These are the two possible values of omega in the format they wanted, this one, REI alpha. Got it. Question number 4. The positive numbers p and q are such that natural log of p over q is a, natural log of q square p is b. Express p to the power 7q in terms of a and b. Okay, so we want this, our target. Yeah, so natural log p over q, okay, plus natural log, I'm adding this and this, okay, natural log q square over p will be equal to a plus b, correct? Because I am adding left side with the left side, right side with the right side. But our target is p to the power 7q, and that is possible because these two natural logs are adding, their multiplications should be this one. That means somehow if I give a exponent x here and exponent y here, then it will become p to the power 7q, but this will not remain equal to a plus b, so I am going to erase it. We'll talk about this later. Okay, so let me say that when two natural logs add up, their contents, whatever is inside bracket, they multiply. So we can say that p to the power x over q to the power x, this one, multiplied by, because they'll become one natural log, right? Q to the power 2y and p to the power just y will be equal to natural log of p to the power 7q, which is our target from here. Okay, so let's collect p now because both are natural logs. So we will compare the inner things. So p to the power x plus y equal to p to the power 7. That gives us x plus y equal to 7. Similarly here, q to the power 2y minus x, yeah, because this is dividing, will be equal to q. That means 2y minus x equal to 1, comparing the powers. Now we got simultaneous equations which we can, I will use elimination method. So I'm adding this one here. So minus x first, then plus 2y equal to 1. So x and minus x, if I add up, cancel out. So it becomes 3y equal to 8. So y's value we got 8 over 3. So now this x is not x, y is 8 over 3. And what about x? Let me use this equation here now. So 2 times 8 over 3 minus x equal to 1. Let me bring the x to the other side. So x equal to 16 over 3 minus 1. Okay, this one comes here. So it becomes 13 over 3 equal to x. Now we will apply them here. So this has been given a power x. So it becomes natural log p over q to the power 13 over 3. Yeah, this is what our x came out to be. Plus natural log of q square p to the power y, which is 8 over 3. So 8 over 3. In natural logs, the exponents of the content become the coefficient of the natural log. So it becomes 13 over 3 natural log p over q plus 8 over 3, both are positive, right? Yeah. Q square p. Now we can write it equal to, because we know this is 13 over 3. 13 over 3. Natural log of p over q is a. And 8 over 3 plus 8 over 3 I didn't write natural log here. Natural log of q square p is b. This is what is equal to natural log of p7 q. You can confirm this by applying these two values here, and you will get exactly same p7 over q. I'm sure about this. So this is what they are looking for. Express natural log p7 q in terms of a and b. So 13 over 3a plus 8 over 3b. Question 5. On a sketch of Argand diagram, shade the region whose points represent the complex number z, satisfying the inequalities this and this. Let's focus on this one first. What it means? It means that z is the complex number with reference to 4 plus 2i. That means on Argand diagram, the distance of z from 4 plus 2i is always 3 or less units, right? So we change our representation in this way. Z minus shows that with respect to this particular point, z is 3 units or lesser. So I have already drawn part of it here. So that means my center of this circle has to be 4 plus 3i. That means this point on the real axis is 4. That means somewhere here it will be 3, then there will be 2, then there will be 1, and this is 0. This is imaginary. That means this center's reference here will be 2i. This is positive 1, right? So any point in this shaded area here is always 3 units or lesser than from this z. Okay, from this point it will be the z anywhere. Suppose z is here, so distance from here to here will be less than 3 always, anywhere I take in this shaded area. That's what it means. So I have shaded the part and I have labeled this. This will be how much? 7, because 3 is the radius from here to here. So this has to be 7. So I will complete this. 5 here and 6 here, and that is 7. Okay. Now this is the first inequality where this circle and shaded part inside. Second, this is the magnitude or modulus of z with reference to 0. There is nothing here. Is greater than, so we can write z minus 0. That with reference to 0, z is closer, greater distance than 10 minus z, means 10 from z. Okay, or z from 10 is the same thing. So I can write this as z minus 0 remains z minus 0 greater than equal to, here I can write minus z minus 10. That doesn't make any difference because this modulus will be looking at the reference distance, not with the sign. So z minus 10 from 10. So if this is 7, 8, 9, I'll have to go further, and this is 10. And this is 0. So distance of z from 0 is greater than z's distance from 10. Exactly in between them is 5. That means we will draw a perpendicular bisector of 0 to 10, which will go through 5, right? And it is lesser towards 10 and more towards 0. That means this part will be shaded, because this part of the circle is closer to 10 than 0, and this becomes our because both of them are equal. Can you see here also equal, and the previous one was also equal, so this will become a solid line here, and this is the shaded part which they wanted us to shade. Okay, I hope you understand. Let's go to the second one. Find the greatest value of argument of z. Argument of z. Again, we'll write this argument of z minus 0. Again, with the reference of 0. From 0, z's argument is greatest. So from 0, I will draw a line first. So let me see what is the smallest argument from 0 here, from origin till the shaded point. Okay, so this is the smallest line which is just touching the edge of this particular shaded place. Okay, so this is the smallest argument we have, which is a negative. Now I'll keep on increasing and go to the other edge. This is the other edge of the shaded part. Okay, let me complete the line with the help of different color. So this is the one. This is the line which is going to the greatest. This is the upper edge of the shaded part, and this is the angle we need to find. Let's call this angle alpha. Okay, so we can see that this adjacent to the alpha is 5. That side is 5. So we can see the tan alpha. Here we can write tan alpha is equal to, adjacent is 5. What about the opposite? So we know up to here at the center it is 2. This distance we want for this alpha from this adjacent line is 2. Yeah, because it was 4 plus 2y, which was the center of this circle. Now we need to find this extra height, and that we can find with this triangle, this right angle triangle. Let's use Pythagorean theorem in this, because this is 90 degree. We know this distance is 1, because from 4 to 5 we have distance 1 here. The radius of this circle is 3, so this is 3, right? And that's how we can find how much is this distance. So by Pythagorean theorem, 3 square is equal to 1 square, and let's call this one as x. Are you using x anywhere? No. So x square. So 3 square is 9 minus 1 equal to x square. So x comes out to be square root 8. 9 minus 1, 8, and then we square root it. Square root 8. So our numerator becomes this 2 plus square root 8. Alright, and now we will find alpha, which is equal to tan inverse 2 plus square root 8 over 5. And I'll put this in my calculator and see what I'm getting. By the time I do this, I will request you to like this video, share with your friends, and subscribe to Math United. That will motivate me to make many more videos like this in future too. What I'm getting here is 0.767 something radians, so I'll say 0.77 radians. Question 6. The equation of a curve is 2y squared plus 3xy plus x equal to x squared. Show that the derivative of this with respect to x is this. Okay, so basically we have to do implicit differentiation in this case because we have two variables. So let's differentiate with respect to x. So if we differentiate this with respect to x, not y, what will this become? 2 will multiply with 2, it becomes 4y. And since we are differentiating with respect to x, we will have to add a suffix, which is dy over dx. Now here x and y, two variables are multiplying, so we will use product rule. In product rule, first we keep constant as constant and one of the variables as one of the variables. Yeah, so just copy it, and we differentiate the other variable. So what is the differentiation of y? Just 1. Okay, but since it is y, we will again use a suffix dy over dx plus, in product rule, again the constant will remain constant and the second variable y will remain y, but we'll differentiate x. And differentiation of x is 1. No need to write. Differentiation of this x is also 1. And this x squared, its differentiation with respect to itself will be 2x. Now we have dy over dx here. We can take them as common. So what is left? 4y plus 3x. And let's bring these to the other side. So we'll get 2x minus 3y minus 1. Yeah, these two become negative here. So dy over dx, by cross multiplication, this part will become denominator of this. So we'll get 2x minus 3y minus 1 over 4y plus 3x, which is exactly they asked us to show. B part, show that the curve does not have a tangent that is parallel to x-axis. Being parallel to x-axis, yeah, this is x-axis, this is y-axis, and being parallel to x-axis means a horizontal line they're talking about. And what is the gradient of a horizontal line? 0. And dy over dx is nothing but that gradient. So 2x minus 3y minus 1 over 4y plus 3x, which was dy over dx, is equal to 0. By cross multiplication, this will multiply here, and we'll be left with 2x minus 3y minus 1 equal to 0, or 2x equal to 3y plus 1. X equal to 3y plus 1 divided by 2. Now, the x coordinate, if there is a tangent, will be where x is equal to 3y plus 1 over 2. Let's see if it is possible by substituting this value in the main equation, which was this 2y square. So I'll write 2y square. Then 3xy, 3, and in place of x, I will write the value I just got, 3y plus 1 over 2. And then we have y also. Then we have x again. Over 2 equal to x square again. The opposite would be better, right? If we would have isolated y. But it's okay. Let's do it, because only twice we had to replace it, but it's okay. Let's see what happens here. 2y square and then 3 over 2 multiplied by 3y square, right? So it becomes 3 over 2, 9 y square over 2. Keep some time to understand this. 3 times 3y is 9y, multiplied by y is y square, and divided by 2. 3 times 1 is 3 over 2y, and all are positive. Then plus, let me separate these also, plus 1 over 2. And now I have to square this one, equal to 4, because 2 square will be 4, and I'll have to square this 9y square. I'm using this a plus b whole square, a square plus b square plus 2ab. This identity I'll use here. So a square I've done already, 9y square plus 1 plus 2 times 3, 6y. Alright. Can we? Yes, we can add these two, right? So it'll become 13, right? 2 times 2 is 4 plus 9, 13y, 13 over 2 y square. What will that be? Both of them have denominator 6y over 2, then half. Then we have here, I'll separate all of them. So 9 over 4y square plus 1 over 4 plus 6 over 4y. Okay, let's bring everything to the left side. So 13 over 2 y square minus 9 over 4 y square, 6 over 2 is 3y, minus 6 over 4 is 3 over 2y, plus half, minus 1/4 equal to 0. All of them, okay, let's take LCM is 4, right? So let's multiply whole of it by 4 and see what happens. So 13, if I multiply this, it'll 2 and 4 will cancel, so it will be 26y square. Then we have 9 times 4, 36 divided by 4, and 4 and 4 cancel, 9y square. Then 3 times 4, 12y, minus 12 over 2, 6y, plus 2 minus 1 equal to 0. So it gives us a quadratic equation now. So 26 minus 9 is 17y square, plus 12 minus 6 is 6y, plus 1 equal to 0. Now they want no solution here. Yeah, they don't want any answer of this one because they don't want any tangent that is parallel to x-axis. That means this should have no solution. And then for no solution, b square minus 4ac, the discriminant has to be less than 0, a negative number. What is ABC in this case? This is A, this is B, and this is C. So it will be 6 square minus 4 times 17 times 1 has to be less than 0. Yeah, so it's 36, and yes, 17 times 4 is 68, which is negative 32, and which is less than 0. It is less than 0. Then you can write, hence there is no tangent which is parallel to x-axis. Question number 7. The diagram shows the curve y equal to, let me write here, y equal to x e to the power 2x minus 5x. So 2x and 5x are different. And its minimum point is m, where x is equal to alpha. Show that alpha satisfies this equation. Since this is a minimum point, m is the minimum point, so we will first differentiate this to find the gradient. So dy over dx. So these two variables are multiplying, right? Power is variable, so this whole thing becomes variable. So we'll use product rule in this one. Let me have some space, and then we'll differentiate this as well. So first I'll differentiate x, which is 1, and I will not touch e to the power 2x because of product rule. Then I will keep x as same, and I will differentiate e to the power 2x, which will be e to the power 2x multiplied by differentiation of 2x, which is 2. So I'll put 2 here. Minus the differentiation of 5x will be just 5. And since they're saying that is the minimum point, at minimum point the gradient of tangent is 0. So this has to be equal to 0. Do we have something common here? Yes, we have this common, but not in 5. So I'll bring 5 to the right side, and I'll take e to the power 2x common from this. So 1 plus 2x, right? So e to the power 2x is equal to 5 divided by 1 plus 2x by cross multiplication. Yeah. Now they want natural log. That means this e must go. And this e can go when the other side becomes natural log. So exponent becomes the normal left hand side, and it becomes natural log 5 over 1 plus 2x. It's matching there. Yeah, 5 over 1 over 2x. All right. Now this 2 also we can divide here by 2 and divide here also by 2. So 2 and 2 is gone. So x is equal to half natural log 5 over 1 plus 2x, which is exactly this, but in terms of alpha. So at x equal to alpha, alpha is equal to half natural log 5 over 1 plus 2x. We've shown it. Yeah. Verify by calculation that alpha, not a, alpha lies between 0.4 and 0.5. So let me copy that equation here. Alpha is equal to half natural log 5 over 1 plus 2x. Now, if this is the solution, alpha is the solution, so you can see that the gradient here is going up, here it is coming down, and we got this from gradient. And also, if an equation has a solution, and suppose this is the equation and this is the solution, see, it is negative below x, it is x-axis, it is below x-axis, it's negative here, and it is above x-axis, positive here. Or the solution can be this way also, positive first and negative later. What is the summary of this? That if the solution lies between 0.4 and 0.5, one of them should give you positive, one of them should give you negative, so that the solution is between them. However, this equation is not in the right format right now, because we'll have to put everything to one side. So I'm bringing this half natural log 5 over 1 plus 2x to the left side, and this is supposed to be 0 for the solution, right? But we don't know the solution yet, so I will not write it is equal to 0. So I will see after substituting 0.4, is it positive, and after 0.5, is it the opposite sign, whatever sign it is. So let's substitute alpha equal to 0.4. So 0.4 minus half natural log 5 divided by 1 plus 2 times 0.4 is 0.8. Just put this in a calculator and you'll get the sign. We are interested in only sign, not the value, okay? Because this is not the solution. By the time I use my calculator, I will request you to like this video, share with your friends, and subscribe to Math United. That will motivate me to make many more videos like this. What I'm getting here is negative 0.11. So we got this case. Before the solution is negative. So only sign is required, okay? Now substitute 0.5. Alpha equal to 0.5 now. And what will that be? 0.5 minus 1 over 2 natural log 5 1 plus 2 times 0.5 1. And in this case I'm getting positive 0.041. So we can see that there is a change of sign, okay, indicates that the alpha lies, alpha in place of alpha, we can also alpha and we can write solution, lies between 0.4 and 0.5. We have verified it. 5. Okay, there must be some C part also. Yes, use iterative formula based on the equation in part A to determine the correct two decimal places, give the result of each iteration to 4 decimal places. So this is what we'll do now. So our equation was alpha equal to half natural log 5 over 1 plus 2 alpha. Yeah, let me verify. Yeah, alpha equal to half natural log 1 plus 2 alpha. Okay, now we have to iterate. So our values were from 0.4 to 0.5, somewhere in between, correct? So which number is exactly between these two? 0.45. So I'll take alpha 1 equal to 0.45. So this iterative formula will be alpha n plus 1. This is what we do. To the one which is isolated, we write n plus 1, and the one which is with the others, just n. So this alpha 1 is actually this one. Okay, so we'll get alpha 2 because of this, which will be half natural log 5 divided by 1 plus 2 times 0.545. This is what I'll put in my calculator, and I'll get value of alpha 2. And this I'll repeat it iteratively till I am stabilized with one solution. So let's see what do we get. I'll fasten this video after this, and I'll explain what I did. So I will stop here. Reason being, if I round it off to 2 decimal places, what do I get here? 0.48, right? Now here I get 0.47. But again here I get 0.48. This becomes 0.47 and again 0.47. So I wrote 4 decimal places of the iteration are rounded off only these 2 times. It is consecutively 0.47, and that becomes our solution, that alpha's value is 0.47. Not accurately, but 2 decimal places it is 0.47. Question number 8. Express 3 sin x plus 2 square root 2 cos x plus 1/4 of pi is in the form of this one, where r is positive, and this a lies between 0 and half pi. State the exact value of r and give correct to 3 decimal places for a. Yeah, so exact value of r. So there are shortcuts also, but let me show you the whole process. So we want sine a plus b. So we should know what is the identity for sine a plus b. It is sine a cos b plus cos a sine b. However, we see one more part here, cos something plus something. So let's write cos also. Cos a plus b is cos a cos b minus sine a sine b. So we want to convert this whole of it into this format. Okay, so for that we'll have to open this one first with the help of this identity. So 3 sin x remains 3 sin x, but 2 square root 2 cos x plus this will be expanded according to this. So cos a cos b, it will become cos x cos 1 by 4 pi minus sin x sine 1 over 4 pi. So I expanded this one according to this identity, and this is what we'll get. We'll evaluate it partially now. So 3 sin x remain 3 sin x, 2 square root 2. Let's open also. So cos x remains cos x, cos 1 over 4 pi is square root 2 over 2. Okay, minus 2 square root 2 again, sin x remains sin x, and cos 1 over 4 pi is also square root 2 over 2. So this 2 cancels with this 2. So we get here 3 sin x plus square root 2 times square root 2 is complete 2 minus this 2 and this 2 again cancel, square root 2 times square root 2 is again complete 2. And that's it. Now we can see this and this are exactly same, so it becomes just sin x. 3 minus 2 is 1, so sin x plus 2 cos x. This is what we have to convert in this format, right? And we'll use this now. So let me expand this here, just below this. So it will become r sin a sin b. So sin x cos a plus r cos x sin a. This is which is given to us, the simplified form, and this is what we want out of it. So see, sin x is here, sin x is here. There is nothing in front, I can write 1. That means this remaining r cos a is 1. Similarly here cos x is here, cos x is here, that means remaining r sin a. Let me write here r sin a is equal to 2. This one. So what will I do now? I'll divide this by this equation. This second equation by first equation, right by right, left by left. So I will divide here r cos a here and divide by 1 here. And the purpose is that r and r cancel. Sin a over cos a is tan a, yeah, is equal to 2. So a becomes tan inverse 2. And we can get this one, right? I'll do that later with my calculator. Meanwhile, let me try to find r also. So if I square this equation, both sides, r square cos square a equal to 1 square, right? Which is 1. This is one of them. I'll square the sine one also, which becomes r square sine square a, this one, equal to 2 square, which is 4. And let's add these two sides. So I'll do it here. R square cos square a plus r square sine square a equal to 1 plus 4. So left hand side added to the left hand side, so right hand side added to the right. R square, I'll take common, it is part of both, so we are left with cos square a plus sine square a equal to 5. We know cos square a plus sine square is 1, so r square is 5 and r will be plus or minus square root 5. But they have clearly said r is greater than 0, that means negative must go, just positive. So the question was expressed in this term. We know r now, we know a now, so we can write it. The final answer will be square root 5, which is the exact value of r, then sine x plus a came out to be tan inverse 2, which I will use my calculator to find out the value of. By the time I do this, I would request you to like this video, share with your friends, and subscribe to Math United. What I'm getting here is 1.11 radians, and this is the format. Okay, this B part also. Hence, solve the equation. This, what is the relation? 3 sin x That means it's doubled. Sine okay, and 2 square root 2 is also doubled. Half theta plus 1/4 pi. Alright, so what if I come, let me minimize this so that I can see them together. Okay, if I compare the two, look here. This 3 is doubled to 6. This 2 square root 2 is doubled to 4 square root 2. But the angle x has been half theta here and half theta here. Everything is same, right? But the coefficients have been doubled and angle has been halved. So I will do what? I will, this was my converted part, so I will convert this accordingly. So it will be 2 square root 5 sine half theta plus 1.11. This is what we have to solve, which is equal to 3. Right? So let's separate this now. Sine half theta plus 1.11 equal to 3 divided by 2 square root 5. Right? So half theta plus 1.11 equal to sine inverse 3 over 2 square root 5. Okay, let me isolate half theta to one side. So half theta will be equal to sine inverse 3 over 2 square root 5 minus 1.11. Now sine inverse 3 over 2 square root 5, let me use my calculator for this to find out. By the time I'm doing this, I would request you to like this video, share this with your friends, and subscribe to Math United. That will motivate me to make many more videos like this. So what I'm getting here is half theta equal to 0.735 minus 1.11, which is half theta equal to negative 0.375. Okay, and that gives us theta equal to negative 0.75, which is in this domain. So correct answer. However, this domain is very, very large. So let's see what other answers we can get. Let me look at the quadrants. So the first sine inverse, I will focus only on sine inverse because that is the one variable, others are fixed. So I got 0.735, that means 0.735 is here positive, yeah? 3 over 2 square root 5 is positive, so this is the answer. And that gave us negative 0.75 as the first possible answer. Let's look at other answers. So I will do what? I will move on to the second quadrant because here also sine is positive, right? So 0.735. This is what I will use now. So I'll use the same equation, which was this one. Half theta equal to sine inverse 2 over 3 square root 5 will be this one. We know this is pi. So I will, in place of 735, I will write now pi minus 0.735. That's the angle we got in place of this sine inverse, and then minus 1.11. So rather we'll multiply by 2 also. So straight away let's write the answer. Theta will be 2 times pi minus 0.735. They are not multiplying, so I can open the bracket. Just put this in a calculator and we'll get the second answer. What I'm getting is 2.593. 2.59. Let's write 2.59. Okay, this is the second answer. Now I'll go to the third one. For third, what will I do? I will not go beyond the 2.59 is the one, right? So okay, we can go there. This is the third answer I can go to because 4 pi is quite far. So I can see if this could be the answer. So it will be what? 2 pi, this is 2 pi, right? Plus 0.735. So theta will be equal to 2 times, I'm taking help of this one now, 2 pi plus 0.735 minus 1.11, which comes out to be 11.817. So 11.8, let me write 11.8, 3 significant figures. This is the third answer. Let's go to the fourth answer. Can I go this way? No, because 11.8 is very close to 4 pi. 4 pi is how much? 12.54. 56 rather. 12.56 and 11.8 is very close to it. So I think this answer will not be needed and I'm sure it will not be needed. So I'm skipping. Now I will go into opposite direction. I need more answers, right? From minus 4 pi also. So I'll go from 0 here to the first angle, which is here. All right, this is the next answer. So theta equal to 2 times. This is minus pi in this case. In negative direction, this will be minus pi. And it is further negative. So minus pi minus 0.735 minus 1.11. This should be our third answer. And this is coming out to be minus 9.97 radians. One more answer, let's try, which will be this one. From 0, I go to this, rather I'll go to next line also. So we have negative 2 pi this one this time. So theta equal to 2 times negative 2 pi, but we are stopping here. That means we are going in positive direction, 0.735. So I'll write plus 0.735 minus 1.11. 9.97 is very far from negative 12.56. So I will see how much it comes out to be. It is it is crossing minus 13.316. So we will reject this answer. So we got our 4 answers: negative 0.75, positive 2.59, 11.8, and negative 9.97. These are the 4 solutions of the given equation. Question number 9. Relative to origin, the position vectors of points A, B, C are given as this: OA, OB, and OC. Okay, show that OABC is a rectangle. Okay, so let's try to visualize them here. This is O, A will be somewhere. So let's assume that this is this way. Okay, I'm not saying this is the right way, but for the sake of understanding, OA is 5 minus 2k. So 5 minus 2k are the coordinates of the point A. Yeah, because that's a position vector. OB is 8, 2 minus 6. So what is the sequence? OABC. So yeah, this has to be. We can't change the sequence, okay? Because it's OABC. So sequence has to be that way. 8, 2 minus 6. It's a 3D grid. So it may look wrong, but somehow in some direction it will be okay. So I'm doing it to make it easy for myself. So 3, 4 minus 7 is for C. I have to prove this is a rectangle. How can I prove this is a rectangle? First of all, we can show that this angle is 90 degree. The OC and OA are making 90 degree angle. So that will prove that one corner is equal. Secondly, I can show that OC's magnitude is equal to the magnitude of AB. So if two sides of a quadrilateral are equal, that means it's a parallelogram. This being equal will prove that they are a parallelogram, and this 90 degree will prove that they are rectangle, right? So these two things we have to prove. So for angle AOC, all right, I have to find OA dot OC. Okay, so let's see what is the dot product of the two. So 5 minus 2k 1. It has to be 1, not k. 5 minus 2 1 dot OC. OC 3 4 minus 7. 3 4 minus 7. Let's see what is the dot product. X multiplies with x. 5 times 3 15. Minus 2 times 4 is minus 8, and 1 times minus 7 is minus 7, which is 15 minus 15, 0. So this proves that angle AOC is a 90 degree angle. Now the magnitude of OC, which is the position vector, will be square of 3 plus 4 square plus negative 7 square. So comes out to be 9 plus 16 plus 49, which is 25 plus 9, 34, 74. Square root 74. Let's see if we get the same magnitude for AB. So first we have to find vector AB. It is not given to us, right? So it will be OB the head minus OA the tail, position vectors. So OB is 8 2 minus 6 minus OA 5 minus 2 1 which comes out to be 8 minus 5 3 2 minus minus 2 4 minus 6 minus 1 minus 7, and again we are getting 3 4 and minus 7 here also. 3 4 minus 7, they are parallel. Obviously their magnitude will also be equal. So AB equal to square root 74 as well. That's why OABC is a rectangle. What about the next part? Use a scalar product to find the acute angle between diagonals of OABC. Diagonals. So this is one diagonal. Let me change the color for this. OABC, this is one diagonal and this is one diagonal. We have to find the angle between the two. For that we will need first OB, right? And it is given to us. The vector OB is 8 2 minus 6, okay, or 8i plus 2j minus 6k is fine. You write this or this column notation. This is algebraic. Okay, now second one, this one AC. So direction we have to be clear. So OB is in this direction, so it has to be tail to tail, right? So okay, so AC will be this way. If I do tail to tail, this angle will be getting. So I have to write CA because this direction I need, right? So CA, not AC this time. Equal to OA. OA is 5 2 minus 1 minus OC the tail 3 4 minus 7. So it comes out to be 2 minus 2 and minus 1 plus 7, 6. 2 minus 2, 6. This is CA. Now to find the angle between them, let's call it theta, will be cos inverse OB dot CA divided by the magnitude of OB magnitude of CA. Right? So let's find the dot product first. OB dot CA equal to 8 2 minus 6 dot CA is 2 minus 2 6, which will be 8 times 2 16 minus 2 times 2 4 minus 36, comes out to be minus 40 plus 16 minus 24. That means we are going to get an obtuse angle. Negative gives us obtuse angle. Okay, let's talk about the magnitude of OB. Magnitude of OB will be 8 square plus 2 square plus minus 6 square. So it will be how much? 64 plus 4 plus 36, which is square root 104. Yeah. So CA its magnitude will be 2 square plus minus 2 square plus 6 square, which is 4 plus 4 plus 36, which is square root 44. Okay, and now we will use the formula we just decided. We'll just find the angle with the formula. Okay, so theta equal to cos inverse minus 24 over square root 104 square root 44. Okay, so it has to be, angle has to be in degrees. Let's do in degrees. Okay, so I'll put this in my calculator and get my answer. By the time I do this, I would request you to like this video, share with your friends, and subscribe to Math United. That will motivate me to make many more videos like this. What I'm getting, as expected, an obtuse angle which is 110.78. So this degrees to one decimal place. So 110.8 degrees is the angle between the two vectors. Question 10. Let the function f be this, where a is a positive constant, any positive constant, express fx in partial fractions. Okay, so first let's assume that 36a square over 2a plus x, 2a minus x, 5a minus 2x, which is the question, is equal to a divided by the first fraction here, which is 2a plus x, plus b 2a minus x second fraction, plus c. All are linear, so no problem. 5a minus 2x. So we'll just because the denominator, if I take LCM of these, the denominators will be same, so I'll just focus on the numerator. For making same denominator, this has to multiply with 2a minus x and 5a minus 2x. So 2a minus x and 5a minus 2x. Similarly, we will multiply with 2a plus x and 5a minus 2x. and C obviously multiplies with 2a plus x, 2a minus x. Okay, now we have to find the values of a, b and c. Well, first we should neutralize this particular bracket. So let's assume let x equal to also 2a. So it becomes 2a minus 2a, right? And that will make it 0. That is the purpose. So left hand side is unchanged. 30, it was 36. So 36 a square. Let me make it cleaner. 36 a square will be the left side. Then this becomes 0. 2a minus 2a is 0, gone. 2a minus 0, 2 minus 2, this also is also a and c are insignificant now. We'll just focus on b. 2a and x we have assumed as 2a, 5a minus 2 times x, which is 2a again. So 36a square equal to b 4a, and this is 5a minus 4a, just a. So b comes out to be 36a square divided by this 4a square, which comes out to be 9. Yeah, 9. Okay, let's assume next now let x equal to minus 2a now. So left hand side remains untouched again, and this will be there a 2a minus 2a. This will be 5a minus 2 times minus 2a. And 2a minus 2a, this will become 0, so gone. 2a minus 2a, this also becomes 0, this is also gone. So this is the only one left. 36a square equal to 4a. And 5a plus 4a, 9a. So 36a square equal to a, and 9 times 4, 36a square again. So gone. A is equal to 36a square over 36 a square, which is 1. Now our target is to eliminate 5a minus 2. So let x equal to, so this has to become 5a, right? So it should be 5 over 2. 5 over 2a. So left side again 36a square. This one becomes 0 because of this 5a. If it is 2x, 2 times 5 over 2a, so 2 and 2 cancelled, 5a. So this will be 5a, 0, this is 0, so C is the one which is left. 2a plus 5 over 2a. Then 2a minus 5 over 2a. Okay. So 36a square equal to C. This will be 2 times 2, 4 plus 5, 9a, 9 over 2a. And this will be 4 minus 5, negative a over 2. So 36a square equal to negative 9a square over 4c. So 4 multiplies here, 36a square times 4 over minus 9a square will be c, cross multiplications. So a square and a square cancel out. Minus 9 gives us minus 4, and c gives us minus 4 times 4 minus 16. So finally the partial fraction becomes a came out to be 1 over 2a plus x. Then we get minus 9, b is positive 9, 2a minus x, and then we got negative 16 over 5a minus 2x. This is the partial fraction. Okay. Next part says, hence find the exact value of this definite integral. So from minus a to a, so we will integrate this now. So let's do them separately. 1 over 2a plus x from negative a to a, then plus 9, let's write 9 outside, 1 over 2a minus x from minus a to a, and lastly minus 16, 1 over 5a minus 2x dx. We have to integrate these, and all of them are linear, so it's not a big deal. So what will we do? This is linear, so it will be, all of them rather will be from negative a to a. This becomes natural log 2a plus x, right? But we have divided by the differentiation of this denominator, which is just 1, so no need to write, plus 9 natural log of 2a minus x. However, this is negative and its differentiation will be negative 1, which will be divided by negative 1. So in place of dividing by negative 1, I will just change the sign of this to negative. Then this one will be minus 16 natural log of 5a minus 2x divided by differentiation of this, because all they are constants, right? A, so their differentiation will be 0, only minus 2. So divide by minus 2. Okay, the differentiation of this, and plus c. And just we have to substitute a and minus a, and we should get our answer. So natural log of 2a plus a, yeah, I'm substituting a first, minus 9 natural log of 2a minus a, and this will be plus 8, right? Natural log of 5a minus 2a plus c minus, and now we'll substitute negative a in all of them. So natural log of 2a minus a minus 9 natural log of 2a minus a plus 8 natural log of 5a minus 2 times negative a plus c. We should first get rid of c's, okay, because c minus c will be 0. So let's see what we get here. Natural log of 3a minus 9 natural log of just a plus 8 natural log of 3a, yes, minus 2a minus a will be natural log of a. Now we have to keep in mind that this is negative, so it will change everything. This is negative, so it will become plus 9 natural log of 3a, this one. Then we have plus 8, it will become minus 8 natural log of 5a plus 2a, 7a. Yeah, that's it. Natural log of 3a, this is 3a and this is 3a. So how much this become? 1 plus 8 is 9, 9 plus 9 is 18. 3a. Okay, now natural log of a and natural log of a, 9 minus 1 will become minus 8. So there are two of them, both are negative. So minus 10, natural log of a minus 8, natural log of 7a. Now let's see what is the format they want. They want p natural log q, and they said q and s are prime numbers. So 3 is a prime number, 7 is a prime number, but they have not mentioned a here. Okay, so that means we have to separate this. So 18 and natural log 3 and a are multiplying. So I can write natural log 3 plus 18 natural log a. 10 natural log a minus 8 natural log 7 plus, rather minus again, because they are multiplying, this negative will keep both of them negative. So my 8 natural log a, right? Now look here, 18 natural log a minus 10 natural log a will be 8 natural log a, and this is negative 8, so they cancel out. 18 minus 18, 0. So we are left with 18 natural log 3 minus 8 natural log 7, and we got it. P comes out to be 18, R comes out to be 8, negative 8, Q came out to be 3, and S is 7. Question number 11. The variables y and theta satisfy the differential equation, this one. It is given that y is 0 when theta is 1/4 pi, so we'll get the value of constants here, solve the differential equation and find tan theta when y is equal to 1. So the first rule for solving a differential equation is that the variables must be together. Like this is 1 plus y, it should be with dy. So let me write it here. 1 plus y is with dy. That means I've ignored 1 plus cos 2 theta, right? It should be theta, and theta should go to it should be numerator, it can't be denominator. So I will write equal to here, and d theta goes and becomes numerator to the other side. 1 plus cos 2 theta should be with it, so it will be here. Okay, so theta is with theta now, and this e to power 3y, no guesses, this y should be with here. So e to power 3y will be with dy, and this is what our two different parts are, and we will integrate them with respect to their respective variables. So it will be with respect to y, it will be with respect to theta. Okay, 1 plus y, let me put e to power minus 3y on top. So when we make it a numerator, the exponent will become negative. 1 plus y dy is equal to, I'll have to make some changes here. So 1 plus cos 2 theta can be written as cos square theta minus sine square, let me have some space, theta. Alright, now 1 minus sine square theta is what? Cos square theta again. So it becomes cos square theta plus cos square theta, which is 2 cos square theta. This is what I will write here, 1 over 2 cos square theta d theta. Okay, now look here. Can I multiply this with y? So it becomes e to the power minus 3y dy, right? And then I'll write this here plus y e to the power minus 3y dy equal to 1 over 2, and 1 over cos square theta is secant square theta d theta. So let me integrate these two first. This obviously this has to be integrated also, and this, right? I will integrate this and this, which are straightforward. So e to the power minus 3y, we copy this for integration and divide by the differentiation of the exponent, which is minus 3, right? Plus there will be a constant also. We'll take care of constant later. This will be, I'll keep it somewhere else. Let me write it here. Y e to the power minus 3y. This is what we have to integrate later. So we'll keep it some space here, and this will be half the integration of secant square is tan theta. Now I will write a constant here. Okay. So now I have to fill up this space by integrating this, and which will be the challenging part because we have two variables. One is exponential, one is algebraic. So we will use our by parts method, which is liat, which will be used here. uv prime is equal to uv minus u prime v. How do I decide u and v? This is liat is the sequence. So this is algebraic, which is y, which will become u, and e exponential will be v. Yeah. So this format is u is u. Okay. So y is our u, and e to the power minus 3 y is our v prime. Okay. This is how we will decide here. So our integration, u is u, which is y. V is not with us, v prime is with us. So if we integrate this, we'll get v, right? So let me integrate this. We have already done that. E to the power minus 3y over minus 3. So that will become this v minus e to the power minus 3y over 3. So I've given that negative, which was denominator, up there, minus integration of u prime. U is y, u prime will be the differentiation of y, which is 1, isn't it? That was the reason we took as u. So 1. I'm talking about differentiation with respect to y only, okay? V, we just got it, e to the power minus 3y over minus 3. And now we can substitute the blank space we had written here. This will be a minus, so I'll have to change this. Let me erase the parts. Here they are. So this will be minus y e to the power minus 3y over 3. This one. Okay. Now minus again, but this minus and this minus will become positive. Okay. Now 1 has no significance, so we'll ignore it. Again, integration of this will be e to the power minus 3y over this minus 3 is already there, and there will be one more minus 3. So it will become positive 9. That means this negative stays. So I will have to change this again to negative because we have one other negative. And it will become positive 9, right? Negative 3 times negative 3 will be positive 9, and this is done constant. Okay. Integration part is done, but our differential equation has not been solved yet. All right. So they have given us this y equal to 0, theta is 1 over 4 pi. So let's put y equal to 0, and when y is equal to 0, theta is 1 over 4 pi. Okay, so e to the power 3 times 0, so e to the power 0 is 1, so it becomes negative 1 over 3. Again, e to the power 0 is 1, so negative y over 3. E to the power 0 is again 1, minus 1 over 9. Alright, equal to half and tan pi by 4. This is 1 over 4 pi, so tan 1 over 4 is 1 plus c. So c stays here, and what do we get? Actually, this y was also 0. Yeah, y is 0, so gone. This is gone. So what are we left with? Minus 1 over, let's write minus 3 over 9 to make it 9, right? Minus 1 over 9 minus 1 over 2 is c. Okay, so LCM is 18 again, so 18, this will be minus 6 multiplied by 2 minus 2 multiplied by 9, so minus 9 equal to c. So 6 plus 2 is 11, 9, 20, minus 20 over 18 will equal to c, which is minus 10 over 9. So the differential equation finally is solved. What was our differential equation? This was the one, right? So e to the power minus 3y over minus 3, so 3 minus y e to the power minus 3y over 3 minus e to the power, all are negative, so we can interchange their places, minus 3y over 9 equal to half tan theta minus 10 over 9. Let's take e to the power minus 3y as common. So what are we left here with? Minus, okay, I'm multiplying everything by negative 1, so it has to be positive now. 1 over 3 plus y over 3 plus 1 over 9, yes, and this will still be positive, right? Because if these 3 go to the other side, or let's give it like this, plus half tan theta, right, plus, because these 3 came with this, and this minus 10 over 9 will go to the side. Basically, I swap their places. This is our differential equation solution, and then they are asking, solve the differential equation and find the exact value of tan theta when y is 1. So tan theta, we don't have to simplify into another thing, just we have to find its value. So when y is equal to 1, so e to the power 3 times 1, and these two can add, right? 3 plus 1, 4 over 9, plus y over 3, and y is given 1, plus half tan theta equal to 10 over 9. Alright, so 4 over 9 plus 3 over 9, yes, 7 over 9. 7 over 9 e to the power minus 3 plus half tan theta equal to 10 over 9. So let me put this here, half tan theta, okay, half tan theta stays here, and that goes to the other side, 7 over 9 e to the power minus 3, since they are saying exact value, right? Exact value. So we have to keep it like this. So 9, we can't subtract this because according to BODMAS, multiplication happens first. So we can take 1 over 9 common. Rather, this 2 will also go and multiply here. So tan theta stays here only, equal to 2 comes and multiplies here, and 9 we have with both of them. Let's take it common, and we are left with 10 minus 7 e to the power minus 3, and to make it positive, I will make it a denominator that is equal to tan theta according to me. This concludes our solution video. So if you liked it, please give it a big thumbs up, share with your friends, let them also watch this solution video, and subscribe to Math United. I'll be motivated to make many more videos like this. Thank you very much.